Let us understand the significance of the term divisibility first. So if I tell you that there is a number 1937265, is this number divisible by 2? Okay, there are two options. You can either divide the entire number with 2 and check the result, or you can use a particular test of divisibility to find out whether the given number is divisible by a particular factor. So the test of divisibility will help you to find out whether a given number is divisible by a given factor, okay, without actually dividing them. Okay, so let's understand the few basic tests of divisibility. We'll start with powers of 2. So if you talk about the divisibility of the number 2, for divisibility of the number 2, we always check the units digit of the number. If the units place is divisible by 2, the entire number is divisible by 2. Makes sense, right? Any even number will always be divisible by 2. And what makes a number even? You look at the units place. If the number is even, if the digit is even, the number will be divisible by 2. So for 2 raised to 1, or basically divisibility of the number 2, we check the last one digit. All right. Something similar you may observe for power of 2, which is 2 square. Okay. So 2 square, which is nothing but 4. For divisibility of 4, you check the last two digits. Okay, so if the last two digits of the number are divisible by 4, the whole number is divisible by 4. Let's take, for example, a random number like 1936. It's not random, by the way, it's 44 ka square. Okay, anyway, so if you take a number like 1936, I take the last two digits, they are 36. 36 is a multiple of 4, so the number 1936 also is a multiple of 4. Okay, likewise, you can check the divisibility of 2 raised to 3, which is 8. For divisibility of 8, we check the last three digits. Okay, so last three digits. Okay, so likewise, you can extend the same logic for all powers of 2. For example, you want to check the divisibility of any number of the form 2 raised to the power n. Okay, for this, you simply check the last n digits. Okay, अगर उस number का last n digits are divisible by 2 raised to n, the whole number will be divisible by 2 raised to n. Okay, let's understand the basic concept behind this test of divisibility right now. So let's say I take a two-digit number, okay, which is written as a b. A is a digit and b also is a digit. Okay, if you expand them, you will basically get 10a plus b. Okay, since a is the tens digit, it will be multiplied by 10, so 10 into a plus b. All right. Now, if you check the divisibility of this number with, let's say, 2, you already know that 10 is a multiple of 2. So what will make the number divisible by 2? If the digit b also is divisible by 2, isn't it? Okay. Let's take one more example. Okay. If you talk about the divisibility of a three-digit number ABC. Okay. Now, three-digit number may A will be the hundredth digit. So the value will be 100A plus. B is the tens place. So 10B. Okay, the last digit is C. All right. Now, if you talk about the divisibility of this number with, let's say, 4, we know that 100 is divisible by 4. What will make the entire number divisible by 4 now? If you make B and C, basically 10B plus C, this part, the last two digits, divisible by 4. Right. So if last two digits like B and C combined, okay, will be divisible by 4, the whole number is divisible by 4. Okay, that's the logic behind this. We have been studying this in school, but now we finally understand why it happens in this way, right? Okay, if you observe carefully, 10 का एक और factor 5 भी है. 10 can be written as 5 multiplied by 2. Similarly, 100 can be also written as 5 square into 2 square, right? 25 times 4. Okay, so whatever divisibility of 2 and powers of 2 we discussed just now, the same tests are also applicable for powers of 5. Okay, so to sum it all up, okay, for checking the divisibility of 5 raised to 1, I again check the last one digit or the unit digit. For checking the divisibility of 5 square, I check the last two digits. For checking divisibility of 5 raised to n, I will check the divisibility of 5 raised to n for the last n digits. All right. So with that, we go on to the next part now. So let's take again a two-digit number. As I said, A, B. All right. Its value can be written as 10A plus B. Okay. Let's write the 10A as 9A plus A. Makes no difference, right? So you can further represent this as 9A plus A plus B, right? Now, for this number 9A plus A plus B, this whole number, 9A wala part is divisible by 3. right? Because 9 is a multiple of 3, right? What will make the whole number divisible by 3? If a plus b, this part also becomes divisible by 3, right? Similarly, if you take a three-digit number, let's say ABC, okay, iska value will be 100a plus 10b plus c, right? Isko bhi you can write it as 99a plus a, 100 को split किया हमने, 10b is nothing but 9b plus b, and write the C as such. Okay. So 99a plus 9b, this part is divisible by 3, right? What will make the whole number divisible by 3? If the remaining part, a plus b plus c, also becomes divisible by 3, isn't it? So for the divisibility of 3, we check the sum of the digits, right? That's exactly what is happening here, right? For a three-digit number ABC, the remaining part becomes a plus b plus c. So if a plus b plus c is divisible by 3, the whole number also becomes divisible by 3. Okay. Same thing you can observe for the two-digit number AB, upper also. Okay. Agar a plus b is divisible by 3, the whole number also is divisible by 3. All right. So simply put up, the divisibility of 3 is nothing but taking the sum of the digits. If the sum of the digits are a multiple of 3, the whole number also is a multiple of 3. Okay. Let's take, for example, a number like 972. Okay. If you add the digits, you get 9 plus 7, 16 plus 2, 18. 18 is a multiple of 3. So yes, 972 also is a multiple of 3. Now, what if I simply add 1 to 972? I will get 973. Now, देखो 972 is a multiple of 3. उसमें हमने एक add किया है. That means when you divide this number with 3, you will obtain a remainder equal to 1. Right? Means ये 3 के multiple से एक ज़्यादा है, isn't it? So when you divide 973 with 3, the remainder will be 1. Okay. Let's check the sum of the digits of 973. 9 plus 7, 16 plus 3 will be 19. 19 mein 1 plus 9 is 10. 1 plus 0 is basically 1. All right. So we have reduced some of the digits to get a single digit. We have basically found the single digit equivalent. All right. So from here we learn that whenever we check the divisibility of 3, just add the digits. Okay. If the digits add up to give you a multiple of 3, the number is divisible by 3. If not, you will obtain the remainder when the number is divided by 3. All right. Now, since 9 and 99 are also multiples of 9 itself, okay, the same test of divisibility can also be applied to divisibility of 9. Okay, so you add the digits. If the sum comes out to be a multiple of 9, the number is a multiple of 9. If not, you will get the remainder when the number is divided by 9. Let's go on further. So with that, guys, we go on to the next part, and that is the divisibility of 7. Now, I will tell you what is the process, but it's very iterative. I mean, it's not something which you do it and get away with that once and like for all. Okay, it is iterative. You have to do it again and again. So let's see. For understanding, I take a number. Let's say 2401. Now 2401 is 49 ka square, so it's divisible by 7, of course. Okay, but just for demonstration, I'm taking it this way. What we do is for 2401 and for any number jiska we are checking the divisibility with 7, okay, we split the units digit. Okay, isko humne split kar diya. The units place I multiply with 2. Okay, now 1 into 2 is equal to 2, right? So from 240, now I subtract this 2, I get 238. Okay, same thing I repeat. Okay, I don't know whether 238 is divisible by 7. Okay, so I repeat it again. I separate the 8s, the units place 8. Okay, I multiply it with 2. 8 into 2 is 16. 23 minus 16 is 7. Is 7 divisible by 7? Yes. So 2401 also is divisible by 7. So as I said, it's an iterative process. इससे better आप क्या 7 से divide कर लो. Okay, 7, 3, 4, 3 times is 2401 anyway. Okay, so I would recommend that for divisibility of 7, you can just divide by 7 and check if you don't remember this. All right, so we go on to the next part now, divisibility of numbers with the number 11. So I'll take one number like 14641. Again, 14641 is 11 raised to 4. Okay, 121 square basically. Okay, so what we do is we start by the rightmost digit, which is 1 in this case, and we add the alternate places. So 1 plus 6 किया हमने, वापस उसमें plus 1 करेंगे. So 1 plus 6 plus 1 will give us the sum as 8. Then we take the sum of the remaining places. Like we take 4 and 4. 4 plus 4 is basically 8, right? So if you observe, the difference of 8 and 8 is 0. All right. So whenever this difference of the difference of the sum you have taken. Okay, alternate places ka sum. Starting with the rightmost place, you take the sum, and then the remaining places ka you take the sum. Okay, if the differences of these two values is either 0 or a multiple of 11, then the whole number is basically a multiple of 11. Okay, we'll take some more examples if you want. Let's say we can take 143. 143 is 11 13s are. So 3 plus 1 is 4. 4 is the remaining digit. 4 minus 4 is 0. Right? So that means the number is divisible by 11. Okay, we take a number 1, 2, 3, 1, 2, 3. Okay, starting with the rightmost place, the starting number is 3. We add 1 to it, then we add 2. Alternate places. Starting from the rightmost digit, you add the alternate digits. So 3 plus 1 plus 2 will give you 6. Okay, the remaining digits are 2, 3, and 1. So 2 plus 3 plus 1 will also give you 6. The difference of these two values is equal to 0. So 1, 2, 3, 1, 2, 3 also is basically a multiple of 11. Okay. Now to observe something similar as we saw in the divisibility of 3 and 9. Okay. If I take the number 14642, okay, this is one more than a multiple of 11, right? So kaide se when we divide this number with 11, the remainder should be 1. Okay. Let's check the divisibility now. 2 plus 6 plus 1 will be 2 plus 6, 8 plus 1, 9. And 4 plus 4 should be 8. 9 minus 8, the difference is 1, the remainder. So just like the divisibility of 3 and 9, okay, same thing is applicable for 11 also. You check the divisibility. If the difference comes out to be 0 or a multiple of 11, the number is divisible by 11. Else, you will get the remainder when the number is divided by 11.